Welcome to the final part of this assignment for streaming analytics. In the first part, we dealt with RDDs using PySpark, and in this part, we'll be dealing with data frames. We are supposed to answer a business question by working with private residential property sales data containing information of private residential units as of end March 2019. The source is located at this Google Drive link here, and it looks something like this. So you can see that there are nested information over here, and this has to be flattened before we can do any manipulation with the columns inside. So first we need to load the data set as a Spark Dataframe object, and to do that we set up the Databricks environment and we load the Spark JSON file. So we turn on the multi-line option and we turn on the header because there is a header here, and we print out the schema. We load the file from file store, which I've explained: import, browse, and you choose the file from your own file directory. We'll run this loading process. Yep, it's loaded successfully, and we can see that this is the JSON file that we are working with. We know that there are multiple hierarchies here with a nested hierarchy right inside containing all the sales related information that we need to answer the business question. So to flatten this nested part of the JSON file, we need to use the explode function, which we have to get from the PySpark SQL functions library. The first part of it is to explode the root file so that we can have a look at all the different hierarchies in the JSON file. We do a count check and we see that there are 131 different entries here. So in this part, if you were to just select the columns without exploding the columns, you would get an array with index in the nested part of the JSON file. So this has to be flattened, and to work around with index arrays, it's going to be quite difficult for aggregation or any kind of data manipulation involving numbers. So to correct this, you need to first explode. The second part of it is to explode the developer sales column. So this is under here, which contains all the sales related information. So after that, you can pull out all the different data types in one single flattened structure. So if you go down here, you will see that these are all these columns here that we need, and we need to assign them to the correct data types as shown here. So some of these are not in the correct data types, so we need to change them. But let's just look at the schema, and you can see that it's all flattened here. So to answer the business question, we need to find out what are the top 20 private residential properties that have the most unsold units in terms of percentage. And to do this, we need to also filter out those data rows that do not have any launch dates. So we cannot keep them into account. So we take those that are already launched and we work around with this data. So after doing a count check, we got about 106 rows of data that have at least some value for launch. So if you were to look at the data types before reassigning them to the correct data types, you can see that these are all in big integer format for both the launch to date and the number of units sold to date. So these two are both in big integer format, and because it's not an array, we can convert it by using the cast method to the respective data type that we want. So let's just select these columns first, since the JSON file is already flattened, and yeah, we'll be working around with this, and we can now display this data frame, which will get something like this. And last but not least, we need to change the number of units launched to date and the number of units sold to date to integers. Here it's shown as big integers, and we also need to change district to integer. So using the cast method we do that, and it's done here. So next we will then create the aggregated column to calculate the percentage sold, which is a column to show the number of units sold to date divided by the number of units launched to date times 100. So we call out a column, a new column, with the name of the column, percentage sold, and we compute the values in these two columns times by 100. So we need to insert the percentage sold column between the project and the number of units launched to date. So we reorder the columns by calling out the select method, and we display it as such. Over here we see that the percentage sold has a very long floating point number. So we need to cut this down to 2 preferably, and we round off the value to 2 decimal places. So here we get the desired table. Now to answer the business question, we need to limit the top 20 private residential properties which have the most unsold units. So we rank from the lowest to the highest sales of residential properties. By using the sort method, we set the ascending to true and we limit to 20. So by doing that, we get a list like this. And after that, we plot the graph to show the distribution. We use Seaborn for more variety in the visualization, and we call pandas. We set the figure size appropriately, the bar plot axis, the labels for the x and y axes, as well as the ticks, and the title, of course. So we would also want to make it more readable, as there are quite a number of plots here. So we use the ax.patches function here to pull out all the bar labels, and then we print out the plot. That's about it. And finally, we can save the output into the Databricks DBFS using the script. So if you go to Databricks, import export data, you can see the files being stored here. Yep, that ends the presentation. Thanks.